Have you ever wondered what would happen if our planet stopped spinning? Imagine a world where one side is eternally bathed in sunlight, while the other is frozen in perpetual darkness. The results would be nothing short of catastrophic for life on Earth. But how would this happen, and more importantly, what would it mean for all of us? In this video, we're diving into the mind-bending science and terrifying consequences of what could happen if Earth's rotation came to a screeching halt. Welcome to Infinitia Verity, your go-to place for exploring the biggest questions and wildest what-if scenarios that science has to offer. If you love delving into intriguing facts, mind-blowing possibilities, and learning about the wonders of our universe, you've come to the right place. Don't forget to hit that subscribe button and click the bell icon to stay updated on all our future deep dives into the unknown. The rotation of the Earth, more than just day and night. The concept of Earth's rotation is something that most people learn about in elementary school, but its implications go far beyond simply creating day and night. The very spin of the planet is crucial to how the Earth functions, affecting everything from the climate to the structure of its interior. Earth's rotation has a fundamental role in everything we experience on this planet. The speed of the Earth's rotation varies depending on where you are on the planet. At the equator, it moves at about 1,670 kilometers per hour, 1,037 miles per hour. This rapid pace slows as you move toward the poles. The Earth's rotation is one of the primary reasons for the Coriolis effect, which influences wind patterns, ocean currents, and weather systems. Without this rotation, the Earth's weather and ocean systems would behave completely differently. Interesting fact 1. Earth is not a perfect sphere. Because of its rotation, the planet bulges slightly at the equator, making it an oblate spheroid. This bulge is a direct result of the centripetal force generated by the Earth's spin. If the Earth stopped rotating, this bulge would eventually flatten, causing shifts in sea levels. Interesting fact 2. Every planet in our solar system spins at a different rate. Jupiter is the fastest spinning planet, completing one rotation in just 10 hours, while Venus rotates so slowly that its day is longer than its year. This diversity in rotational speeds is due to the conditions under which each planet formed. The impact of inertia, unstoppable winds. Inertia is the concept that objects in motion tend to stay in motion unless acted upon by an external force. It's a basic principle of physics, but when applied to the Earth's sudden halt, the consequences are staggering. We are all moving along with the Earth at incredible speeds, whether we realize it or not. If the Earth stopped, the atmosphere, oceans, and everything on the surface would continue moving at their previous velocities. The power of wind beyond hurricane strength. When the Earth halts, the atmosphere continues moving. Winds reaching speeds of up to 1,670 kilometers per hour, or 1,037 miles per hour, would tear across the planet. These winds would be far more devastating than any natural disaster humanity has ever encountered. To put this in perspective, Category 5 hurricanes, the most powerful hurricanes, have wind speeds of around 252 kilometers per hour, or 157 miles per hour. Now multiply that by 6. Buildings would be shredded, trees uprooted, and entire cities leveled in seconds. The energy involved is beyond anything modern engineering is prepared to withstand. Real-world examples of wind's destructive power. One of the most significant examples of the power of wind is Hurricane Katrina, which struck the Gulf Coast of the United States in 2005. Katrina's sustained winds reached about 175 miles per hour, or 280 kilometers per hour, and the damage was catastrophic, with thousands of homes destroyed and the city of New Orleans flooded. However, if we imagine winds more than 6 times stronger than Katrina's, no city would be safe. Interesting fact 1. The winds on Neptune, the windiest planet in the solar system, can reach speeds of up to 1,500 miles per hour, or 2,400 kilometers per hour. Although Earth's winds would not quite reach that speed, the results would be devastating, with everything in their path obliterated. Interesting fact 2. Winds of 1,000 miles per hour are far beyond the speed of sound, which is about 767 miles per hour, or 1,234 kilometers per hour at sea level. This means that the winds generated by Earth's halt would be supersonic, creating sonic booms across the planet and tearing apart anything in their path. The fate of the ocean's mega-tsunamis. While the winds would wreak havoc on the land, the oceans would be no less chaotic. Imagine a gigantic bowl of water that suddenly comes to an abrupt stop. What happens to the water inside? It surges forward. On Earth, the oceans are constantly in motion due to the planet's rotation. If that rotation stopped, the water would continue moving, crashing into coastlines with unprecedented force. Mega-tsunamis, coastal cities wiped out. The oceans would be hurled eastward in massive waves, mega-tsunamis that could reach hundreds of feet in height. These waves would be unlike any natural disaster we've ever seen, capable of flooding entire continents and wiping out coastal cities in an instant. Fun fact: the Indian Ocean tsunami of 2004 was one of the deadliest natural disasters in human history, killing more than 230,000 people across 14 countries. The wave that struck Indonesia reached heights of over 100 feet or 30 meters. However, the tsunamis created by a halting Earth could be over 10 times taller. Another interesting fact: the sheer volume of water moving in these tsunamis would have the power to reshape coastlines, submerging large portions of land permanently. Entire countries could disappear beneath the waves in just minutes. The long-term effects on the oceans. Once the initial chaos subsides, the oceans would settle into a new equilibrium. Without the rotation of the Earth, the oceans would likely migrate toward the poles due to the flattening of the Earth's shape. The equator would be left dry, while massive bodies of water would accumulate at the poles, drastically altering the geography of the planet. Earthquakes and volcanoes. The planet rumbles. As we move beneath the surface of the Earth, the situation grows even more dire. The Earth's crust is composed of massive plates that float atop the semi-fluid mantle. These plates are in constant motion, driven in part by the planet's rotation. If the Earth suddenly stopped, these plates would experience an unprecedented shock. Catastrophic earthquakes. Earthquakes occur when tectonic plates grind against each other, releasing energy in the form of seismic waves. In the event of a sudden halt, this energy would be released all at once, triggering massive earthquakes worldwide. These quakes would be far more powerful than anything ever recorded, as the planet's stored rotational energy is released. The ground would crack open, buildings would collapse, and entire regions would be leveled. The Ring of Fire, a major earthquake zone encircling the Pacific Ocean, would likely experience the worst of the devastation. Countries like Japan, Indonesia, and Chile, which are already earthquake-prone, would be hit the hardest. Interesting fact 1. The largest earthquake ever recorded was the Great Chilean Earthquake of 1960, which had a magnitude of 9.5. This quake caused widespread destruction and triggered tsunamis that reached as far as Japan. In our scenario, earthquakes of this magnitude would occur across the globe simultaneously. Interesting fact 2. Earthquakes release energy in waves that travel through the Earth's crust. The seismic waves generated by Earth's sudden halt would likely travel much faster and farther than those from natural earthquakes, spreading destruction even to areas that are usually seismically stable. Supervolcanic eruptions, the Earth's pressure cooker. The sudden halt of the Earth's rotation would also disrupt the delicate balance of pressure beneath the Earth's surface, leading to widespread volcanic activity. Supervolcanoes like Yellowstone in the United States could experience catastrophic eruptions. These eruptions would release massive amounts of ash, gas, and lava, covering entire regions in a thick layer of volcanic material. Fun fact 1. A supervolcanic eruption at Yellowstone could release 1,000 cubic kilometers of ash and lava, enough to cover the entire United States in several feet of ash. The last time Yellowstone erupted was about 640,000 years ago, and the effects were felt across the globe. Fun fact 2. Supervolcanoes have the potential to cause volcanic winters, where ash and gas block sunlight, cooling the Earth's surface for years. The eruption of Mount Tambora in 1815 caused the year without a summer, leading to crop failures and famine across the world. The magnetic field, Earth's protective shield. The Earth's magnetic field is generated by the movement of molten iron in the planet's outer core. This magnetic field acts as a shield, protecting the Earth from harmful solar radiation. If the Earth stopped rotating, the dynamo effect that generates the magnetic field could be disrupted, leaving the planet vulnerable to cosmic radiation. Solar and cosmic radiation, a world without protection. Without a magnetic field, the Earth would be exposed to intense solar winds and cosmic radiation. This radiation would destroy satellites, fry electronics, and disrupt power grids. More importantly, it would pose a serious threat to life on Earth. Interesting fact 1. The magnetic field not only protects us from solar radiation but also helps to maintain our atmosphere. Without it, the solar wind could strip away the atmosphere over time, similar to what happened to Mars. Mars once had a much thicker atmosphere, but without a protective magnetic field, it was gradually lost to space. Interesting fact 2. The northern and southern lights, or auroras, are caused by the interaction between the Earth's magnetic field and charged particles from the Sun. If the Earth were to stop rotating, disrupting or weakening the magnetic field, these beautiful light displays might become more intense for a brief period due to increased solar wind exposure. However, this would be a fleeting spectacle. Over time, the disruption of the magnetic field would leave the Earth vulnerable to harmful cosmic and solar radiation. The demise of auroras and consequences for life. Auroras are more than just an awe-inspiring display of nature's power. They are a visible reminder of the Earth's protective barrier. If the magnetic field weakens or disappears, auroras would eventually vanish, and with them, our last defense against the destructive forces of space. Solar winds would bombard the surface, and cosmic rays, high-energy radiation from outside the solar system, would permeate the atmosphere. This would lead to a dramatic increase in radiation levels, which would have devastating effects on all life forms. Cellular damage, cancer rates, and mutations would skyrocket as life on Earth struggles to cope with the constant exposure to high levels of radiation. Interesting fact 1. The Earth's magnetic field extends far into space, creating a region known as the magnetosphere, which shields us from solar wind and cosmic rays. Without this magnetic shield, the upper layers of the atmosphere, particularly the ozone layer, would be eroded over time, further exposing the planet to harmful UV radiation. Interesting fact 2. Other planets in the solar system, such as Mars, once had magnetic fields but lost them over time, which is one reason why they lack thick atmospheres. Scientists believe that without Earth's magnetic field, our planet would slowly become like Mars, a barren, lifeless world devoid of its protective atmospheric shell. The sky without a day-night cycle, eternal day and night. One of the most immediate and visible changes would be the disappearance of the regular day-night cycle. If the Earth stopped rotating, one side of the planet would be locked facing the sun, while the other side would be in perpetual darkness. This would have profound consequences for life as we know it. Eternal day. The blistering heat. On the side of the Earth facing the sun, temperatures would soar to unbearable levels. Without the rotation of the planet, there would be no way to distribute heat evenly, resulting in scorching temperatures that could reach well over 120 degrees Celsius or 248 degrees Fahrenheit. Fun fact: the Moon experiences something similar, with days and nights lasting about 14 Earth days each. The side of the Moon facing the sun becomes incredibly hot while the dark side plunges into freezing cold. This would be the fate of the Earth, though on a much larger and more extreme scale. Eternal night. The freezing cold. On the other side of the planet, which would be locked in perpetual darkness, temperatures would plummet to below freezing, resembling conditions on the dark side of the Moon, where temperatures drop to minus 173 degrees Celsius or minus 280 degrees Fahrenheit. The cold side of the Earth would become a frozen wasteland, with the absence of sunlight plunging regions into eternal winter. Interesting fact: the atmosphere plays a significant role in regulating Earth's temperature, but without sunlight, even the atmosphere would not be enough to prevent extreme cooling on the dark side. Oceans would freeze solid and life would struggle to survive in these frigid conditions. Another interesting fact: In regions near the boundary between the day and night sides, there might be a thin, habitable zone where temperatures are more moderate. However, this narrow strip of twilight would be constantly battered by violent winds, making it a treacherous place to live. Agriculture and food production. The collapse of global systems. Life on Earth depends on the regular cycling of day and night to regulate photosynthesis, the process by which plants convert sunlight into energy. Without a regular day-night cycle, ecosystems would collapse and food production would become impossible. The collapse of agriculture. On the sunlit side of the Earth, the intense heat would make it impossible for crops to grow, as plants would be scorched by the relentless solar radiation. On the dark side, the freezing temperatures would cause plants to wither and die. Global agriculture, the backbone of human civilization, would cease to exist. Interesting fact: photosynthesis is the basis of nearly all food chains on Earth. Without it, there would be no way to produce the energy required to sustain ecosystems. While some deep-sea organisms survive without sunlight, they represent a tiny fraction of life on Earth and could not support the global food web. Another interesting fact: hydroponic farming and vertical farming techniques, which allow plants to grow indoors using artificial light, could become a lifeline in this scenario. However, scaling these technologies to feed the world's population would be an enormous challenge. Human survival. Could we adapt? In the face of such extreme environmental changes, human survival would become increasingly precarious. Populations living on the sunlit side of the Earth would need to seek shelter underground or in highly fortified cities to escape the intense heat. On the dark side, people would need to survive in insulated, heated environments to avoid freezing. Water, oceans, and life. A changing planet. Water, the lifeblood of Earth, would undergo dramatic changes if the planet stopped rotating. Oceans, rivers, and lakes would no longer experience the natural cycle of evaporation and precipitation that drives the global water system. Instead, the water cycle would break down, leading to dramatic consequences for all forms of life. The ocean's redistribution of water. The cessation of Earth's rotation would cause the centrifugal force that pushes water toward the equator to disappear. Water from the oceans would migrate toward the poles, creating vast polar oceans while leaving equatorial regions dry. This would cause catastrophic flooding in polar regions and widespread desertification in the tropics. Fun fact: the Coriolis effect, which influences the movement of water and air, would no longer function. This would cause major disruptions in ocean currents, which play a critical role in regulating Earth's climate. Without these currents, global weather patterns would be dramatically altered. Fun fact: the redistribution of water would create new coastlines and reshape the geography of the Earth. Entire landmasses could disappear beneath the rising polar oceans, while regions near the equator might become vast deserts. The water cycle: no more rain. On the sunlit side of the Earth, the intense heat would cause any remaining bodies of water to evaporate rapidly. However, without the global circulation of air, there would be no way to distribute moisture across the planet. This would lead to the end of the water cycle as we know it. No more clouds, no more rain, and no more rivers or lakes to sustain life. Human civilization: the end of society as we know it. The cessation of Earth's rotation would not only bring environmental catastrophe, but also the collapse of human society. Our global civilization is built upon the assumption of a stable, rotating planet. Without this foundation, the systems we rely on, electricity, communications, transportation, food production, and governance, would fall apart. Technological collapse. Satellites, which rely on the Earth's rotation to maintain their orbits, would fail, leading to the collapse of global communications networks. Power grids, already vulnerable to the effects of solar storms, would be destroyed by the increased radiation from the sun. Without these technologies, modern society would quickly unravel. Interesting fact 1. The Carrington event of 1859 was the most powerful solar storm on record. It caused widespread damage to telegraph systems across Europe and North America. If a similar event were to occur without the protection of the Earth's magnetic field, it would wipe out modern electronics and plunge the world into chaos. Interesting fact 2. The collapse of the global financial system would follow shortly after. Stock markets, banks, and supply chains would grind to a halt, as there would be no way to communicate or transport goods. The world would descend into anarchy as resources became scarce and governments struggled to maintain control. Philosophical and existential reflections humanity's place in the universe. In the face of such overwhelming destruction, humanity would be forced to confront its own vulnerability. The cessation of Earth's rotation would not just be a physical disaster, it would also be a profound philosophical and existential crisis. What does it mean to be human in a universe where even the most fundamental forces of nature can be disrupted? The fragility of human civilization. The end of Earth's rotation would be a stark reminder of the fragility of human civilization. Despite our technological advancements, we are still at the mercy of the forces of nature. This scenario would force us to re-examine our relationship with the planet and with each other. Interesting fact 1. Throughout history, humanity has faced existential threats, from asteroid impacts to pandemics. However, the cessation of Earth's rotation would be unlike anything we have ever encountered, a global catastrophe that no amount of preparation could fully mitigate. Interesting fact 2. Some philosophers argue that humanity's ultimate destiny may lie in space colonization as a way to escape the limitations and dangers of living on a single planet. This scenario might spur renewed interest in space exploration as we seek to find new homes beyond Earth. So what do you think? Could humanity survive a scenario where the Earth stops rotating? Let us know your thoughts in the comments below. And if you enjoyed exploring this fascinating and terrifying what-if scenario, don't forget to like the video, share it with your friends, and subscribe to Infinitia Verity for more mind-bending content. Click the bell icon so you never miss another deep dive into the mysteries of our universe. See you in the next video.